Hello, and welcome to this edition of the PULS Power Show. I'm Ed Merkel, and we are pleased to present to you this series of videos aimed at demonstrating the key features that you should be considering when selecting a power supply. Today's video will focus on the importance of energy consumption and what impact efficiency and power factor can have on the energy costs over the life of the application. Everyone is talking green these days, but PULS has been focused on high efficiency and energy savings for many years. The basic formula for calculating current is taking the power and dividing it by the voltage. This formula works when the efficiency is 100% and the power factor equals 1. Since a power supply is not 100% efficient and most designs have less than 1 for power factor, the basic formula for calculating current cannot be used. The formula for calculating the input current of a power supply is as follows. You would take the output power of the device and divide it by the sum of the input voltage times the efficiency of the supply times the power factor. The next slide will show some simple current calculations with various parameters for 240 watt supplies. Using the simple formula for a 240 watt supply with 120 volt input, the base current would be 2 amps. If we take a supply and make it 93% efficient, we can see how it affects the input current. There's not much of a change because of the high efficiency, but it has increased the input current. The next calculation will take the same 93% efficient power supply and give it a 0.98 power factor. Once again, since the power factor is so high, the input current only increases slightly. However, if we take a different 240 watt supply with only a 75% efficient rating and a power factor of 0.6, the current calculation is more than 2 times that of the previous supply with high efficiency and power factor. Since both power supplies do the same amount of work, why would you want to pay more than twice in energy cost? Let's take a look at a working example of several 240 watt supplies. Each of these units is connected to the same type power meter, which we'll use to measure different parameters. Each supply is connected to an identical 240 watt load and is energized with the same AC source. Let's start out with the PULS Q series unit, and the only value we cannot read directly from the meter is the efficiency, which is listed at 92.3% at 120 volts found in the datasheet. If we take a look at the watt readings, you will see that the unit is drawing around 250 watts. This is the input watts, so if the unit is delivering 240 watts to the load, this PULS unit is only losing around 10 watts, mostly in the form of heat. If we take a look at the power factor reading, the PULS unit has about a 0.98 power factor. Finally, if we look at the amp draw, the unit is drawing around 2¼ amps, which is similar to the current calculations we showed earlier in this video. High efficiency and power factor result in a lower input current. Now let's see how the other two competitive models compare to PULS. The first competitive unit has an input watt rating of around 270 watts or around 30 watts of heat loss. This unit has a lower power factor around 0.66 and the input current is around 3½ amps. The datasheet for this supply has the efficiency listed at 88%. It is understandable why this unit has a higher input current, as the power factor and the efficiency are lower than the PULS unit. Looking at the second competitive unit, the input watts is around 279 watts or 39 watts of heat loss, and this unit has a higher power factor of 0.99. The input current is around 2½ amps, which is in large part due to the higher power factor. The efficiency rating listed in the datasheet is 84%. Let's take a look at the overall comparison. The first competitive unit produces 200% more heat and uses 200% more energy as compared to the PULS unit. The second competitive unit produces 290% more heat and uses more energy than PULS. Both competitive models use substantially more energy to operate the same 240 watt load than PULS. We're going to let these units run for several hours so that we can see how many kilowatts are actually used. In the meantime, let's take a look at a similar amperage linear supply to see how it compares to PULS. This is a 12 amp 24 volt unit that has no efficiency rating listed in the data sheet. This unit is quite a bit larger and heavier than the compact PULS unit. The meter shows that the unit requires around 338 watts to operate the same 240 watt load used in the other demonstrations. The power factor is around 0.73 and the input current is around 3.8 amps. The sheer size of the heatsink would indicate that the efficiency rating is low, which is traditionally found in linear supplies. This unit is subject to derating due to many factors, and so sometimes an even larger unit is required to operate the same load. The comparison slide shows that this linear unit uses 880% more energy to operate the same 240 watt load. That is a lot of wasted energy, especially today when everyone is so focused on green. Well, it has been around 12 hours now, and let's see how many kilowatts have been used during this time. For the PULS unit, around 2.92 kilowatts have been used. For the first competitive unit, around 3.14 kilowatts have been used. And finally, for the second competitive unit, around 3.29 kilowatts have been used. Since it is impossible for you, the viewer, to touch these units, we will use an infrared thermometer to see how warm each of these units are running after several hours. Starting with the PULS unit, you can see that the temperature is around 44 degrees C. The first competitive model has a reading around 52 degrees C. And finally, the second competitive unit has a temperature around 50 degrees C. These are the measurements used only for a single supply. But what if an application is using 50 to 100 supplies? Think of the extra energy that is used and the extra heat that is produced. Buying the lowest cost supply, which may not minimize your input current or heat loss, may end up costing you substantially more money. PULS has the overall lowest application cost because of our small size, high efficiency, and low input current. This can save money on enclosures, cooling, maintenance costs, and most importantly, energy. Thank you for joining us. If you have additional questions, please call us or refer to our website where we have additional information on our products and applications. All of us at PULS would like to thank you for joining us today, and we look forward to seeing you on our next edition of Pulse on Power.